In this video, we're going to be diving into what graphs mean, how to read them, and how they reveal everything about the behavior of a function. So let's get into it. A graph is a visual representation of all the input and output pairs, x and y, that make up a function. Think of it like a map. For every x value you plug in, the graph shows you the height or output of the function. As we can see, if we plug in -2, we get 4 up here. If we plug in -1, we get 1. If we plug in 0, we'll get 0. If we plug in 1, we'll get 1, and 2, we'll get 4. The x-axis is your input, and the y-axis is your output. And we're going to plot every point x and y, and the graph appears like a picture of the function's behavior. Not every graph you see is a function. We can easily tell though by using the vertical line test. If any vertical line touches the graph more than once, it fails. That means there's an x value with more than one output, and that breaks the definition of a function. So if we look on the left at y equals x squared, when we do the vertical line test, our vertical line only touches the function once. On the right though, with x equals y squared, when we do the vertical line test, we can see the vertical line touches our function at more than one place. It touches it at 2 different places, which means this is not a function. Graphs are not just pictures. They are full of information. Here's what you can spot instantly: intercepts, increasing, decreasing behavior, maximum and minimums, symmetry, and continuity. These can be very helpful when solving problems. So let's look at examples. From this graph, we can easily identify the x and y intercepts. So our x-intercepts from the graph would be right here at -2, 0, and right here at 2, 0. So they would be -2, 0, and 2, 0. Now our y-intercepts will be all the way down here at 0, -4. We can tell that our function is increasing and decreasing just by looking at the graph. We can see that the function decreases all the way until it gets to x equals 0, the minimum of this graph. So it's decreasing from -infinity all the way to 0. So we're decreasing on the interval -infinity to 0. Now we are increasing from 0, when x is 0, all the way till +infinity. So express that as 0, infinity. And that is how you can tell whether your function is increasing or decreasing by looking at the graph. We can also easily find the maximum or minimum of our function by looking at the graph. Looking at our graph for x squared minus 4, we can see that this is a parabola opening up. So the vertex is a global minimum, which occurs down here at 0, -4. This means our lowest point, our minimum, is 0, -4. Looking at the graph of our functions, we can easily identify the symmetry. On the left, we have f of x equals x cubed, which is an even function, and it mirrors over the y-axis. It looks the same reflected over the y-axis. On the right, we have f of x equals x cubed, which is an odd function and has rotational symmetry about the origin. X cubed rotated 180 degrees about the origin looks the same. Graphs are also a great way to show continuity. Here is a classic example of a function that's not continuous. F of x equals 1 over x has a vertical asymptote at x equals 0, which is right here. This is because you can't divide by 0. X cannot equal 0. As you approach 0 from either side, the values of the functions shoot off towards negative and positive infinity. That's a break in the graph. To draw this graph, you'd have to lift your pencil. That's what makes this function discontinuous at x equals 0. That was a quick introduction of what a graph really shows. If this helped, like the video and subscribe for more easy math explanations. Thank you for watching.